Hello students, in our last classes we have seen some operation on matrices like matrix addition, matrix subtraction or matrix multiplication by a scalar. So today we will see how two matrices are multiplied. So suppose this is one matrix, one question I am solving from exercise 3.2 actually. Given question number 1 of exercise 3.2, given A is equal to 2, 4, 3, 2 and B is equal to 1, 3, minus 2, 5. How to multiply these two matrices? So we have to find the value of A, B, means matrix multiplication of A and B. So how we will do matrix multiplication? So first of all we have to multiply this row with this column. Again this row with this column. So 2 into 1 plus 4 into minus 2. Next will be first row is completed with first column. Next we will move to second row. 3 into 1 plus 2 into minus 2. 2 into minus 2. So second row first column is complete. Means first column is multiplied with both row 1 and row 2. So we will move to second column. Now we will move to second column. So second column again this is the first row. So second column will first multiply with first row, then to the second row. So this is 2 into 3 plus 4 into 5. This is 3 into 3, 3 into 3 plus 2 into 5. So what will be the value? 2 minus 8, 3 minus 4. 3 2s are 6 plus 5 4s are 20, 3 3s are 9 plus 5 2s are 10. So minus 6 minus 1, 26. This is 10 plus 9 is 19. Yeah. So this is the result of the matrix AB. This is the matrix multiplication. This is little bit complicated actually, not so easy, but if you learn the process it will be very easy for you all. So for matrix multiplication we have to notice one thing. How many rows are there and how many columns are? This is ordered 2 by 2. And what is the order of this matrix? This is also ordered 2 by 2. So before doing matrix multiplication, first of all you check whether the matrix multiplication is possible or not. The number of columns in the first matrix should be equal to the number of rows in the second matrix. Means what I have said, number of columns in first matrix should be equal to number of row in second matrix. So this is the condition for the multiplication of matrix. Remember this point. So this is all about matrix multiplication. So I am solving another question. Another question I am solving. Question number 13 of exercise 13.2. If f of x is equal to cos x sin x 0 minus sin x cos x 0 0 0 1. Show that fx into f of y is equal to f of x plus y. We have to prove f of x into f of y is equal to f of x plus y. So what is given here? Fx is equal to this. So we have to find the expression for y. So what will be the value? I am not writing this again. So what will be the f of y? Simply this x will change to y. Cos of y, sin of y, 0. Here it will be minus sin of y, minus sin of y, cos of y, 0, 0, 0, 1. So now what we have to do? Fx into fy, fx into f of y, fx into fy. So what is fx? Fx is fx, I am writing here. Suppose this is fx cos x minus sin x, or minus sin x 0. This is minus sin x cos x 0 0 0 1. And what is f of y? F of y is cos of y minus sin of y 0 sin of y 0 cos of y 0 0 1. So what will be the multiplication of these two matrices? What I have told, first we have to multiply with first column. So first row with first column. So cos x will be multiplied with cos y. So it will be cos x cos y. Second, minus sin x sin y. Minus sin x sin y. Next will be 0 into 0 is, it will be 0. So it will be plus 0. Next what I have to do, I have to, first row is complete. So you have to move on second row. Second row should be multiplied with first column. So sin x into cos y is sin x cos y, sin x cos y. Sin x cos y plus cos x sin y plus cos x sin y. Next is plus 0 into 0 is 0. Next we have to multiply 0. Second row is complete, we have to move for third row. So third row, first column. 0 into cos y is 0 plus 0 into sin y is 0 plus 1 into 0 is 0. Next we will move to first second row, because first second row not move to second column, because first column is completed for all the three rows. Three rows are completed with first column. We will move to second row, second column. So cos x minus sin y, it will be minus of cos x sin y. Next it will be minus sin x cos y, sin x cos y. Next it will be 0 plus 0, it will be 0 into 0 is 0. Next we will move to second row, second column. Sin x minus sin y, minus of sin x sin y. Here it will be cos x cos y plus cos x cos y, cos x cos y. Here it will be 0 into 0 is plus 0. Next it will be 0 into 0, third row, third row, second column, yeah. 0 into minus, it will be 0. 0 into cos y will be 0. And another will be 1 into 1. 1 into 0, it will be plus 0. Next we will move to third column. So third column, first row, it will be cos x into 0 is 0. Is it visible? This part is actually not visible, so I am writing it here. So don't don't get confused. It will be visible here, I think. Yeah, cos x into cos x into 0 is 0. Next it will be 0 plus 0. Next 0 into 1 is plus 0. Next row, it will be sin x into 0 0 plus cos x into 0 will be 0 plus 0 into 1 will be 0. If we move to third row, 0 into is 0 plus 0 into this is 0 plus 1 into 1. 1 into 1 will be 1. So this is the matrix. After calculation, what I have seen, cos x cos y minus sin x sin y. So we can write this as cos x. Cos x plus y. Here we can sin x cos y plus. So here we can write sin x plus y. It will be 0. Next it will be minus, if I take common cos x, then it will be cos x sin y plus sin x sin y. Cos x sin y plus sin x sin y. So it will be minus sin of x plus y. Here also cos x cos y minus sin x, cos x cos y minus sin x sin y. So what will be the value? Cos of x plus y, and third will be 0. And what is this term? 0, 0 and 1. So now compare this matrix. Is it visible? Now compare this matrix with this. See, here it was x, here it was y. When it is f of x, it is x. When it is f of y, this is these terms are y. Now it is f of x into f of y. Now it is coming x plus y. So what will be the result? Result will be this. So we can say is equal to, this value is equal to this. And how this cos x plus y comes? This is one trigonometric formula. You have studied the trigonometric formula in class 11 also. So what is the formula for cos